In this presentation, we will continue on with our comprehensive problem, this time taking a look at the direct labor cost variance. This will be a similar process as the direct materials variances. What we're going to do to start off this time is to hide a few cells, because what we want to be able to see is our data up top. So we're going to hide some of the cells below, and we're going to hide the entire rows. What we're going to do then is put our cursor on cell 53 or row 53 right on the number and highlight the entire row. I'm going to then hold down the left click on 53 all the way down until we get to the data that we are working with here, which is the labor variance. So I'm going to scroll down to line 105, and the direct labor cost variance is below. Then I'm going to right click on that. Don't delete it. We're just going to hide it. So remember, hide down here, not delete, hide. So we're going to hide this information. And there we have it. If you hit delete by accident, it'll ask you, do you really want to do this? And you're going to say, no, I just want to hide it. And then, of course, now we've got row 52 to 106 indicating those hidden cells within them. We're going to do a similar type of process here. We'll do this with a pictorial type method, and then we'll go through more of a formula type method. So we're going to compare actual sales, which will be actual quantity. So AQ, actual quantity, times the actual price. And we're going to compare that to the standard quantity, SQ, times the standard price. That's going to be our overall comparison we'd see on the budget. And then we're going to break that down into its components, giving us the price variance and the quantity variance. So let's get these numbers first. We're going to say the actual quantity is going to be equal to, and I'm just going to scroll up to the actual quantity information. We're looking for the actual quantity for the labor this time, and that's going to be the 23,000 hours. 23,000 hours, and then we've got the actual price. So actual price is going to be equal to, we'll scroll up to the data. The actual price is $10.20 per hour. Then we'll multiply those two out. So we'll say this equals the 23,000 times the $10.20, or the 234,600. Now let's take a look at the standard quantity and the standard price. And we're going to get those up top. Now I've scrolled all the way up here. Note that if we take a look at the quantity, we have the direct labor is 1.9 per unit. And remember that we're assuming a capacity at 20,000 times 75%, 75% of capacity, which is 20,000, or 20,000 times 0.75, 15,000. That times the hours per unit, which is 1.9, it's going to give us the 28,500. 28,500. Let's do that in our worksheet. So we're going to scroll down to our worksheet. We're going to go to the standard quantity and say that that equals, and we'll scroll all the way up top then. We're going to scroll all the way up top, and we're looking for the direct labor. So there's the direct labor hours, 1.9 per unit times, and then 20,000 units times 0.75, or 15,000 units. And I have an equals instead of times there. That should be times. And enter. So in other words, it's going to be B7 times E17 times E16. And then we're going to go over here to the standard price, and that's going to be equivalent to or equal to, scrolling all the way up top, the standard or budgeted number of the labor. It was the $10. $10. So there we have that, and we can multiply them out as well. We're going to say this equals the 28.5 times the 10. Now, if we took the difference between these two, that would be our total difference, but we need to further break that out into its component parts, which is the direct labor rate variance and the direct labor efficiency variance. In other words, the time, how much time was spent, how many hours variance, and the difference in how much we paid people, the rate variance. So to do that, we're going to go to our middle area to see this in a pictorial fashion. And we're going to take the actual quantity times the standard price. So actual quantity times the standard price. And we're going to say, all right, the actual quantity is this number. And the standard price we already got is that number. Multiply these out. This is going to be actual quantity times the standard price. And then we're going to take the difference between the actual sales and our budgeted, flexible budgeted information. We're going to say this equals, usually taking the larger number, just always come up with a positive number. This number minus this number. Now again, we could say, well, is that good or bad? Note what was held constant. This one was held constant. Therefore, we're concentrating on the actual price versus the standard price. The actual price was higher than the standard price, or what actually happened is higher than what was budgeted to happen, and that's not good. So we're going to say that's unfavorable. And then on this side, we'll do the same thing. This equals the 285,000 minus the 230,000. So the 55,000, and again, we'll say, okay, what was held constant here? Well, the price was constant. Using the standard price, the difference was the actual quantity and the standard quantity. And between the two, the actual quantity is less than the standard quantity. And you would think that's good, right? We used less than we would think. And so if you consider this, you'd say, we paid more for the units than we thought we would have, and we used less quantity. And you might say, that kind of makes sense because maybe we bought better material or something like that, and therefore had a favorable quantity. So the question then is it a net gain? Is it a net good thing to buy better material and have our usage of the material waste possibly go down because we paid more for the material? It looks like an unfavorable difference for the price. And we used less material, however, so we had less waste with the material possibly. So if we go through that, we're going to say, okay, well, that gives us I'm just going to list out what we have here. The direct labor rate variance then is going to be equal to this number. That's the rate variance because that's where we changed the rate amount, the price in this case, and we knew that that's going to be unfavorable. And then we'll list out the other one we're going to call the efficiency variance. So, and that's kind of basically the quantity variance because how efficient were we with the material that we had. And that was equal to the 55, and that was actually favorable. So that's a favorable difference. So we have to subtract these two out because one's favorable, one's unfavorable. I'm going to take the higher number minus the lower number, and there's our total difference, and we're going to call that the total direct labor variance, and it is going to be favorable. And once again, of course, that's the same as saying if we were to take then the total amounts here, this 285,000, missing a zero, 285,000 minus the 2346, that's going to be our 50,400 here as well. So here's our total difference. Here's us breaking it out between the labor rate variance and the efficiency variance. Okay, so now we're gonna look at this in a little bit different way. We'll just basically calculate what the direct labor cost variance is in a kind of a straightforward way, the way we would basically kind of assume that it would be on possibly a budgeted financial statement. So we're gonna say the actual cost then. We'll start off with the actual cost, and we'll say it's gonna be the actual units times the actual price. So the actual units, if we scroll up top, were the 23,000 for direct labor. And then we'll take that and multiply it times the actual price. The actual price was equal to, if we scroll up top, it's equal to the $10.20. And then if we multiply that out, we'll get the actual cost. So the actual cost is equal to the 23,000 times the 1020. Then we're going to get the standard cost. So we'll take the standard cost, and it's going to be the standard units. So the standard units, if we scroll up to the top, I'm going to say equals, and scroll up to the top here, the standard units is going to be 1.9 hours per unit times 20,000 if we were at capacity, but we're only operating at 75% of that, 15,000. So 20,000 times 75% times 1.9. That gives us the 28,000. Then the standard, or kind of like budgeted price, is going to be equal to, if we scroll back up top, the standard or budgeted price is going to be the $10. And if we multiply that out, we'll get the standard cost. So the standard cost is equal to the 28.5 times the 10. That gives us the 285,000. And the total then, if we subtract these out, equals, I'm going to take the larger number minus the smaller number. And that's just another calculation of our total difference, which we calculated here. So it's the same as basically this minus this. We're just doing it in a more up and down, probably familiar type of format. The total difference, which we then broke out in a pictorial form between these two items, the direct labor rate variance, the direct labor efficiency variance. Now we're going to break that out using formulas, and this will be the most straightforward or fastest kind of method to do this. So the alternative solution method, we're going to say, here's our formula for the rate variance. It's going to be the actual hours times the actual rate minus the standard rate. And notice that we use actual hours, an H instead of a Q. So you could, if you wanted to just memorize one formula, you can kind of use the Q as instead of the H's as we did before, and that way that basically the formulas will be the same for the two types of variances for materials and labor. So you can kind of, they're going to be the same type of thing. You just got to remember, of course, that when we're talking about quantity for labor, we're talking about the number of hours, and then the rate, of course, is the hourly rate. So here we have that, and times the actual rate minus the standard rate. So of course, when you're considering the formula related to the rate variance, the thing that will change is the rate, actual rate minus the standard rate. And we'll multiply that by the thing that you got to kind of memorize, which is the actual hours. So we're taking the actual hours. Now we're just going to plug in the numbers and do the math here on this item. And remember, we should probably bracket the second component here, put brackets around this. So we're looking for the actual hours. So if I say equals and scroll up to find the actual hours, we're going to say that that is 23,000. And then we're going to say the actual rate then. The actual rate, if we scroll up, is going to be the 10.2 minus the standard rate equals, and I could actually pull that here, the standard rate, standard price, 10. And then I'm just doing the algebra. I'm going to do the subtraction first, equals the 1020 minus the 10. And we'll just bring down the 23,000 on this side, and then multiply that out. So this equals the 23,000 times the 0.2, 4,600. That should be equivalent to the 4,006 we have up top. So just another way to calculate this using a formula. And if you consider this for long enough, you'll be able to kind of see how what we did here, if you break that down into its, distill it down into its smallest part of formula, you'll come up with these formulas. All right, so then we're going to do the quantity variance, which of course takes the difference in quantity, that's the thing that changed, actual quantity or hours minus the standard quantity or hours times the standard rate. So we're going to say, all right, so the actual hours are going to be equal to, and we'll scroll up looking for the actual hours, it's going to be the 23,000. And then we're going to go to the standard hours, which will be equal to, if we scroll up, the standard 28.5, and then we'll multiply that times the standard rate. So the standard rate is going to be equal to, if we scroll up, the standard price, the $10. Now remember, these two should be bracketed here. We're going to bracket these two this time, this one and this one. So we'll do the subtraction first, in other words. And I'm going to say, now this one will come out negative if we do it the way the formula is. We often express it just as a positive number. So we have this item, the 10 will be brought down. And then we're going to say this equals the 5,005 times the 10. And there's the 55,000 unfavorable. So, and that of course matches the 55,000 that we calculated up top for the direct labor efficiency variance. Okay, then if we were to subtract those, I'm going to add them with a formula because we're, the 55,000 minus the 4,006 is the 50,400, which again we calculated here. We see the total here, 50,400.